listeners, welcome back. So today, we're going to be looking at IonQ and
Oh, yeah.
some really cool stuff they're doing in the quantum computing world.
Some big news from them.
Yeah, we've got their press release and
Article from...
an article from Quantum Insider to sort of unpack it all. So
Yeah, I think this is a big deal to kind of set the stage for why it's a big deal. Quantum computers have incredible potential, right, to revolutionize medicine and materials and everything, but they're really expensive to operate.
Yeah, it's the cooling, right?
Yeah, they have to operate at super low temperatures.
Yeah.
Like almost absolute zero, which requires these huge cooling systems.
Yeah.
And so that's like a big barrier to making quantum computing more practical.
So is IonQ claiming to have solved that?
It seems like it, yeah. So they've created this miniaturized vacuum package for ion traps that can operate at room temperature.
So no more giant cooling systems?
Potentially, yeah.
Wow, okay, so how does this even work?
So it all comes down to this thing called extreme high vacuum.
Okay.
Which is super important for trapping ions.
Right. Yeah.
And ions are kind of at the heart of IonQ's quantum computers.
Okay, so how extreme are we talking about?
Like the surface of the moon extreme.
Wow.
Yeah, it's that empty.
So how do they even create that kind of environment here without huge...
Right, so they're not using those traditional vacuum pumps with all the moving parts. Instead, they're using these advanced materials and optics and really precise microscale manufacturing to create this sealed environment that maintains that vacuum.
So fewer moving parts.
Yeah.
Fewer things to break down.
Right, exactly.
Okay. But in terms of size, how much smaller are we talking about here?
Well, potentially, instead of these room-sized computers, you could have something, like the size of a server rack or even smaller eventually.
So you're saying on a desk?
Yeah, maybe even integrated into devices.
So we're not talking about sci-fi quantum computers anymore. This is...
All right, this is tangible now.
Yeah.
Yeah. And remember those energy guzzling cooling systems?
Yeah.
If we get rid of those, that makes it a lot cheaper to operate.
Much more efficient and eco-friendly, potentially.
Yeah, exactly.
All right, so it's smaller, it's cheaper.
And there's also maintenance to consider.
Oh, okay.
So instead of needing specialized technicians, you could have these modular components that are easily swappable.
Like Legos.
Yeah, kind of like that.
So less downtime.
Right, at a lower cost.
So it's making quantum computing feel less intimidating.
Exactly. And this is where scalability comes in.
Okay.
So if it's easier to maintain, cheaper to produce, we can start making a lot more of them.
So it's more accessible then.
Right. And then they can be adopted across all sorts of industries.
Okay, so we've talked about the technology now. Let's in the next part, let's talk about what that means for the real world.
Right. Let's get into applications.
Yeah, like medicine, materials, AI, all that good stuff.
Definitely. So applications, let's start with medicine.
Okay.
Imagine designing personalized drugs.
Okay.
Tailored to a person's genes.
Oh, wow. So treatments would be more effective?
Yeah, and with fewer side effects.
Yeah, because they're so targeted.
Right, exactly. And we could even understand complex biological processes. Like in ways we can't even imagine right now.
So breakthroughs in disease prevention.
Yeah, or even aging.
Wow. Okay, so medicine, that's huge. What about materials?
Oh, yeah, material science.
Yeah.
So imagine creating materials with properties we've never seen before.
Like what?
Like super strong but super lightweight. Or materials that conduct electricity with no resistance.
Like a superconductor.
Right, exactly. And quantum computers could help us actually design and discover these materials.
So this could revolutionize tons of industries then.
Yeah, like aerospace, energy, all sorts of things.
It's like a technological renaissance.
Yeah, pretty much. And then there's AI.
Oh, yeah. AI. How does that fit in?
Well, quantum computers could help us develop AI that's even smarter than humans.
In what ways?
Like pattern recognition.
Oh, okay.
Complex decision-making, maybe even creativity.
So machines that can think.
And potentially outthink us.
Yeah, that's...
It's a little scary.
It's a bit of a Pandora's box, isn't it?
It is, but remember, AI is still a tool.
Right.
Even quantum-powered AI, so it's up to us to use it for good.
Okay, so it's not just about the technology itself.
Right, it's about how we use it.
It's about the impact it has.
Exactly.
Okay, so bringing it back to IonQ,
yeah,
it seems like their miniaturized vacuum package is a catalyst.
It is, yeah.
For all this innovation.
It makes quantum computing more accessible.
More practical.
Exactly.
So it's a pretty big deal.
It is. Yeah, definitely something to keep an eye on.
And who knows what other breakthroughs are coming.
Right. This is just the beginning.
Okay, well, before we get ahead of ourselves, let's recap what we've talked about today.
Okay, so we started with the challenges of quantum computing.
Yeah, the size, the cost, the energy.
Right, all of that.
And then IonQ came in with their solution.
The miniaturized vacuum package.
Room temperature ion traps.
No more cooling systems.
And we talked about the benefits.
Smaller, more efficient, easier to maintain.
And then we got into the potential applications.
Medicine, materials, AI.
All that good stuff, so.
Yeah, it's been a good deep dive.
It has, but
But there's one more thing I want to touch on.
Okay, what's that?
So as quantum computing becomes more powerful and more common,
yeah,
we have to think about how we use it responsibly.
Responsibly, okay. It's kind of like we need some rules, you know?
Yeah, like an ethical framework.
Yeah, for how we develop and use this technology.
Right, because we don't want to just advance it for the sake of advancing it.
Yeah, we have to think about the impact.
Exactly.
So it's not just about the qubits and all that.
It's about the people.
Yeah, making sure it benefits everyone.
And that's going to be the real challenge, I think.
More than the tech itself?
Yeah, it's a social challenge, an ethical one.
It's going to take everyone working together.
Yeah, and having these conversations.
That's why this deep dive has been so important.
I agree.
We started with this cool new tech.
Yeah.
But we ended up talking about some really big questions.
About the future.
Yeah, like what does it all mean?
It's been great.
It really has. So I guess the big takeaway is...
Well, as we keep going deeper into this...
Into quantum computing.
We have to keep asking those tough questions.
Yeah.
Be excited, but also cautious.
Make sure we're using it for good.
That's the goal.
Well said. Well, thanks for joining us, everyone.
Yeah, thanks for listening.
We've covered a lot today.
From the tiny details to the big picture.
And it's clear that this field is moving fast.
Super fast.
So we'll be keeping a close eye on it.
Definitely.
And we'll be back with more deep dives soon. So until then, stay curious.
Keep exploring.
And we'll see you next time.